Okay, this is the video for pre-calculus for Friday, May 22nd. Okay, the sheet that we're using is this one called Sum Limits Practice. Okay, if you don't have it printed out already, print it out. Okay, I'm going to do a bunch. You're going to have to finish the rest for homework. So, starting with number 2, the limit as x approaches 0 of 3 to the x plus 1 over 3 to the x minus x. Well, you always plug in first and see if you get a value that's the actual limit. 3 to the 0 plus 1 over 3 to the 0 minus 0 is 1 plus 1 over 1 minus 0. 1 plus 1 is 2. 2 minus 0 equals 2. So, the answer to number 2 is 2. Number 3. The limit as x approaches 0 of 1 plus x squared minus 1 over x. Well, when you plug in 0 over here, you get 1 plus 0 is 1. 1 squared is 1 minus 1 is 0 over 0. So, 0 over 0. As you may recall, that means it's indeterminate, and we need to do more to be able to get it. So in this case, what we're going to do is we are going to multiply 1 plus x times 1 plus x. So it's the limit as x approaches 0 of 1 plus 2x plus x squared minus 1 over x. This came from 1 plus x times 1 plus x. Okay? The 1 and the negative 1 cancel. So you have the limit as x approaches 0 of 2x plus x squared over x. Now, if you plugged in 0 again, you would get 0 over 0. We're going to factor the x out of the numerator. X times 2 plus x over x. The x's are going to cancel, and now I'm left with 2 plus x. I'm going to plug in the 0. 2 plus 0 is equal to 2. 2 plus 0 equals 2. Okay, that was number 3. You can pause it at any time and look, okay? After number 3, we go on to number 6. Number 6 says the limit as x approaches 3 of x squared minus 9 over x minus 3. So, if we were to plug in 3, you would get 9 minus 9 is 0, over 3 minus 3 is 0. We would end up with 0 over 0 again, which is indeterminate. So we have to factor and cancel or do whatever necessary. In this case, factoring and canceling. X plus 3, x minus 3, difference of 2 squares, over x minus 3. The x minus 3's cancel. You're left with x plus 3. Limit as x approaches 3 of x plus 3. Now when you plug in, that's when you don't need to write the whole limit again. 3 plus 3 is equal to 6. Okay? The next one, number 7. The limit as x approaches 4 of the square root of x minus 2 over 4 minus x. If I plug in 4, square root of 4 is 2. 2 minus 2 is 0. Over 4 minus 4 is 0. 0 over 0, once again, that's indeterminate, so we have to do something. As you'll recall from earlier, when we have those radicals, we multiply by the conjugate. So we're going to multiply by square root of x plus 2 over the square root of x plus 2. So we get the limit as x approaches 4. When you have conjugates, the middle terms cancel, so you have the first and the last. Square root of x times square root of x is x, minus 2 times plus 2 is minus 4. And over here in the denominator, we have 4 minus x times the square root of x plus 2. 4 minus x goes into x minus 4, negative 1 times. Okay, so this goes in that negative 1 times. We're going to use the 4. We're going to plug in negative 1 over the square root of 4 plus 2. Square root of 4 is 2. 2 plus 2 is 4. Negative 1 over 4 is the answer to number 7. Moving up, there you go, negative 1 over 4. Moving right along, after 7, I'm jumping ahead to number 13. The limit, as x approaches 3, of 9 minus x squared over 5 minus the square root of x squared plus 16. If I plug in a 3, 9 minus 3 squared, 9 minus 9 is 0. 3 squared is 9 plus 16 is 25. Square root of 25 is 5. 5 minus 5 is 0. Once again, 0 over 0 is indeterminate. So what are we going to do? Well, we have to get rid of the radical in the denominator. We're going to use that. We're going to multiply by the conjugate again. Okay, so for number 13, the conjugate of this is 5 plus the square root of x squared plus 16. Whatever you do to the denominator, you must do to the numerator. So, now, what do we have? The limit as x approaches 3 of 9 minus x squared times 5 plus the square root of x squared plus 16 over the when you multiply these, the middle terms cancel out. 5 times you end up with 25 minus parentheses x squared plus 16. And when you distribute the negative, it becomes 25 minus x squared minus 16. 25 minus 16 is 9. So you're left with 9 minus x squared. So we have the limit of, as x approaches 3, of 9 minus x squared times 5 plus the square root of x squared plus 16 over 9 minus x squared. The 9 minus x squareds are going to cancel. I'm going to plug the 3 into here. I'm going to go down to the next line. And I'm going to end up with, actually I'm going to keep going. So you have 5 plus the square root of 3 squared plus 16, right? Which is equal to 5 plus the square root of 9 plus 16 is 25. 5 plus 5 equals 10. That was number 13. So went from here to here. Those canceled, so we would just had that, but with that I plugged in the 3 to what was remaining. And then I got this. Okay, that was 13. After 13 comes 16. The limit as x approaches 0 of 6 to the negative 1 minus 6 plus x to the negative 1 over x. If I plug in a 0, I get 6 to the negative 1 minus 6 to the negative 1 is 0 over 0 once again. Well, first, let's see what this is even without the negative exponents, what it looks like. So 6 to the negative 1 is 1 over 6 minus 1 over 6 plus x all over x, right? So the way we're going to do that is we're going to use the lowest common denominator, which is 6 times 6 plus x. Okay? Because this is over 1. Okay? So I'm going to multiply by 6 times 6 plus x. 6 times 6 plus x. 6 times 6 plus x. And the 6's are going to cancel. And the 6 plus x's are going to cancel. And we're going to be left with the limit as x approaches 0 of 6 plus x minus 6 over 6x times 6 plus x. Okay? So, here we're going to end up with the limit, hold on, I didn't show that over here. 6 minus 6 is 0, so we're left with x over 6x times 6 plus x, and the x's from here cancel. We're left with a 1 up there. 1 over 6 times 6 plus 0. 1 over 6 times 6 is 1 over 36. Okay? That was the answer to number 16. Number 18. Okay, now we're doing the different types. Now we're going from those to approaching a number to now the limits as x approaches positive or negative infinity. So for number 18, which is what we've been doing, we did this on Monday and Wednesday, the limit as x approaches infinity of x over x squared minus 1, well, the degree of the denominator is greater than the degree of the numerator, so therefore the answer is 0. Because the numerator is less than the denominator, or the denominator is greater than the numerator, however you want to say it. So that was number 18. Number 19, the limit as x approaches infinity of x cubed over x squared minus 1. Here, the degree of the numerator is greater, which means that it's going to be some form of infinity. Well, it's positive. Positive cubed is positive. Positive squared is positive. Positive over positive is positive. So the answer, number 19, is positive infinity, and the numerator is greater than the denominator. For 20, the limit as x approaches negative infinity of 2x squared over x squared minus 1. The degree of the numerator is equal to the degree of the denominator. Therefore, it's the ratio of the coefficients. So the answer to number 20 is really a 1 in front of here. 2 over 1 is 2. And that's because the numerator equals the denominator. Okay? After number 20, I'm going to go to the ones with the graph. Okay? Let's see. Okay, the 27, the limit as x approaches 3 from the left-hand side. Well, here's 3. As it's approaching 3 from the left, the y values are getting closer and closer and closer to negative 3. So 27 is negative 3. 28, the limit as x approaches 3 from the right-hand side, is also negative 3. So the limit as x approaches 3, what do you have to do? If the going from the left and from the right match, then that's the answer. So the answer is negative 3. However, f of 3 is not there because it's an open circle. It's up here. F of 3 is 3. Okay? And if I want to go to number 33, without telling you what 31 and 32 are, but I am going to have to look at 33. The limit as x approaches 5. Well, the limit as x approaches 5 from the right-hand side is not the same as x approaches 5 from the left-hand side. So the limit for number 33 does not exist, but you'll have to say what they both are there. Okay? So the limit as x approaches 5 of f of x does not exist because it's not the same from the right and from the left. Your homework is to finish this entire sheet, okay? We did a lot of it, but you must do the rest. Hope you all have a good day. This will be due on, today's Friday. This will be due Sunday night. Okay, have a good day.